So we have two different formulas. One for a population, one for a sample. They are the same formulas, they're going to give us the same answer, so if you made a mistake and didn't know if it was a sample or a population, you would still get the same answer. However, it is probably good to know which one you're dealing with. Most of the time in the real world, we are dealing with samples. Very rarely do we have 100% of the information. So, the mean absolute deviation is the sum. Remember, this Greek letter means to sum up. These lines mean absolute value. So if we have a negative value in there when we're done, you always make it positive. It's the sum of the absolute values of the individual score minus the mean. So let's go back to what we talked about last class, which was everyone's age in here. So if I figured out the mean age was 21, so what I would do for this is I would take the first person. Say she is, how old are you? 18. So we take 18 minus 21 is negative 3. That makes it positive, so it's positive 3. Then we add it to the next person minus the mean when it's positive. We add it to the next person and the next person and so on. So we take the score, we subtract the mean, we make it positive, we add it to the next score minus the mean and so on. Once we summed all those up, we just divide by the total number of people in the room, and this will give us an indication of how spread out the blob is. Alright, this might seem intimidating, but I'm going to show you an easy way of solving it. And that is, here's the procedure for how to do it, but let me show you in a table first. This is all you're going to do. We're going to go back to the example, but set up a table. You're going to have your x values. You're already going to know what the mean is, because you probably already calculated it or it will be given to you. And you subtract the mean from all these values. And then you're going to have an x minus x bar column. So x, which is 2.2 minus the mean, turned out to be negative 0.115. So you do that all the way down. So 2.4 minus the mean turned out to be 0.085. Then you make another column that's all these positive. Now if you're doing this on an exam or something, obviously, or a project or at work or whatever, you're not going to have to make another column. You can simply, once you have all these, just put little plus signs in front of them, right? But in this case, I wanted to show you, so now these are all these values but positive. So we're going to sum up all of them, and this is the sum of all the absolute values of x minus x bar. So let's actually do the question here. Below are measurements gathered from 10 Red Fox tracks. The front foot lengths are given to us. And last class, we calculated the mean. The mean is 2.315. All right, so we are going to take 2.315 and subtract it from 2.2. So this is my x. I subtract 2.315 from it, and I get negative 0.115. I take 2.25 and subtract 2.315 from it, and I get negative 0.065, and so on. Then I make them all positive, I sum them all up. I take that and put that into the formula. So 0.55 divided by n. What's n? How many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 numbers, so it's 0.55 divided by 10. And my answer is 0.055 inches. On average, if I find a track of a red fox front foot on the ground, on average, its length is going to be 0.055 inches away from the average fox size, the average size of a fox's foot. So it tells you how spread out it is. If this turned out to be, like 10 inches, then they're going to be all over the place. But it makes sense that they're not going to be. An adult red fox's foot, they're all roughly the same size. You're not going to have one that looks like this big and one that's like this big if they're all adults, right? They're all going to be roughly the same size. Think about us as humans. You go into a shoe store, they carry a certain range of shoe sizes. They don't carry them all over the place, right? because we all tend to be fairly tightly grouped together. All right, any questions on the mean absolute deviation? The easiest way to do this is with the table. So regardless of when you have to do this, an exam or whatever, set the table up like this and just fill the blanks in. And then you can even make notes ahead of time, beforehand. Add this column up, put it here in the formula, divide by 10. Okay, next. So the problem with the mean absolute deviation is this. Remember the target I had with the person that got a few bullseyes and then some of the others were scattered? What if, like 4 of the person's arrows ended up 10 feet over there? Well, those are going to substantially affect the mean absolute deviation because they're extreme values. Well, if there are extreme values, you can get a better indication of the spread of the data with this, which is the median absolute deviation. If we took those golfers' salaries, including Tiger Woods' salary would affect the mean absolute deviation, but will not affect at all the median absolute deviation. This one is pretty much immune to extreme values. So the first one, we took the center and we figured out the distance, the mean. We took the mean and figured out the distance of the arrow to the mean and add them all up and then figured out the mean of those distances. For this one, everything is median. So the middle is the median, so we're going to figure out the distance from the arrow to the median, not the mean. So we're going to have all these distances, and then instead of figuring out the mean of those, we're going to figure out the median. So we're going to find the median distance to the median. The first one we found the mean distance to the mean. So this is going to be the median distance to the median. So the median absolute deviation is the median absolute amount by which the scores deviate from the mean. From the median. See, now I got myself confused. Unlike the mean absolute deviation, outliers do not affect the median absolute deviation. So the extreme values will not affect this unless we have an overabundance of them. But in general, the extreme values won't bother us at all. So instead of looking at the procedure, let's actually look at the table. So here's the same thing we did before, and we want to figure out what the median absolute deviation is. So I list out all the tracks. This time I subtract the median from them, not the mean. So the median that from last class was 2.325. So I subtract that from all the scores. So 2.2 minus 2.325 turns out to be negative 0.125. 2.25 minus 2.325 is negative 0.075. We do that for this whole column. Now, just like before, we take the absolute value of these. All right. Now we have to find the median of these values, not the mean. So we're not going to add this column up and divide by 10. We're going to figure out the median. So you remember how we do that? We sort this from smallest to largest. So I have to take all these, sort them, and put them over here. So the smallest number I had is 0.025. 0.025. I take all those, put them here. I have a 0.075, a few of those, and a 0.125. So these are listed from the smallest to the largest. Now I find the median. And remember how to do that? We just take our finger, like this, and I'm left with 2 values. So if I have 2 values left, I add them up and divide by 2. So my median absolute deviation is 0.05. So that is not affected by those extreme values. Now, if there's no extreme values, then the mean typically is going to give you a better indication of how spread out the data is. We only are going to use this if we have some extreme values. right, so that's the median absolute deviation, or M with a little d